their compounds. Non-metals and their compounds is what I said here. Our subtopic is nitrogen. So under this subtopic, we are going to concentrate on mainly about the how can you prepare nitrogen and the uses of nitrogen. So that is our specific objectives or specific issue that we are going to do is how can you prepare nitrogen gas and the uses of nitrogen gas. So the issues or issues to be discussed mainly issues, that means main issues is laboratory preparation of nitrogen, and secondly is about uses of nitrogen. And under uses of nitrogen, we concentrate on application as fertilizers in production of ammonia. We will also talk on the manufacture of nitric acid and etc. So my dear students, starting with the introduction, what is nitrogen and how, where can we find it? Is that nitrogen is a non-metal element. Is a non-metal element, and if it's a non-metal element, its atomic number is 7. So if we write its electronic configuration, so nitrogen, its electronic configuration is 2, 5. So there are 5 electrons in its outermost shell, which means that to attain stability, it needs 3 electrons. To attain stability, that is the electronic configuration of noble gases. And the nitrogen exists. It exists in the atomic molecule. The atomic molecule that is of this formula. And it is a gas. It is a gas under room temperature. Now, since it is a gas, we will see its application later where nitrogen can be applied. Now, can we discuss some occurrence of nitrogen? We have the occurrence. Where can we find the nitrogen? Nitrogen is mainly found in the atmosphere by a percentage of 78 by volume. So you remember about the air composition when you studied in form 2 class. So here the occurrence of nitrogen is that it occupies 78% by volume in air. Do you remember the composition of air, where nitrogen have 78%, oxygen have 21%, we have carbon dioxide have 0.0391%, and the remaining percentage is for other gases like noble gases and the vapor. So the main occurrence of nitrogen is in the atmosphere, but we have other forms of occurrence of nitrogen. we have other forms of occurrence of nitrogen. Here is that the other forms of occurrence, other forms of occurrence is that nitrogen can be also found in combined state as can be found in combined state as nitrates and the oxides. As oxides, that means as nitrogen oxides or nitrates. In nitrates we have also nitrogen. But also in living organisms, that means in animals and the plants. So it also occurs in animals and the plants. A good example here, we have protein. I know you know proteins. We living organisms eat protein from plants. But also, inside our body, there is a process known as protein synthesis. Now, how is protein synthesized? Or how protein is formed? It's by amino acids. So amino acids combine together to form protein. So many molecules of amino acids combine together to form proteins. So inside our body we have protein, also in plants we have proteins. So now let us see how can you prepare nitrogen gas. So the preparation of nitrogen gas. Now, my dear students, normally nitrogen gas can be prepared in the laboratory by isolation from the atmosphere. So it can be prepared in the laboratory by isolation from the atmosphere. Since we have said that nitrogen is present in large amount in the atmosphere, so what is being done is that the air from the atmosphere is collected, can be collected by different methods. For example, using a bicycle pump. Then after collecting the air in the atmosphere, the air is passed through sodium hydroxide. So when the air is passed through sodium hydroxide, carbon dioxide is dissolved by sodium hydroxide. So which means that in the composition of air, we have said that there is nitrogen, there is oxygen, there is carbon dioxide, and the other gases like inert gases. So here, when carbon dioxide dissolves in water, then the composition that remain in the air is oxygen and the noble gases. So the reaction behind which is taking place is that when now air is passed through the sodium hydroxide, is that carbon dioxide, which is a gas now, is being dissolved into sodium hydroxide and resulting into formation of sodium carbonate, sodium bicarbonate. So sodium bicarbonate is formed after passing the carbon dioxide into sodium hydroxide. But later on, the air is again passed through heated copper. So here that again the air is passed through heated copper. And what the aim of passing the air through heated copper is for trapping oxygen gas. So which means that oxygen gas when passed through heated copper, then the copper reacts with the oxygen to form copper oxide, which is solid. And there is a change in color. Copper solid is brown, and resulting into formation of black solid substances, which is due to formation of copper oxide. So do you see now the air? We have said that air is composed of nitrogen, oxygen, then you have carbon dioxide, and the other air, other composition, which is inert gases, and the moisture. So now within this composition, after passing it through sodium hydroxide, carbon dioxide have been dissolved. Then passing that air through copper, heated copper, oxygen have been dissolved. So what have been remained here is inert gases and nitrogen gas. So this nitrogen gas now is collected through over water, because it is almost insoluble in water. So it is collected over water, and if collected over water, the nitrogen that is collected over water is not pure due to presence of some inert gases, whereby now other processes of purifying it are being done. Now, to show the setup experiment on how nitrogen gas is prepared in the laboratory, here we have our setup apparatus showing how nitrogen gas is being prepared in the laboratory, where this is now water in. So when you may use the water, allowing it flowing into the aspirator, but at the beginning the aspirator must be empty. So at the beginning the aspirator must be empty. Why? If empty, that means there will be air in. So once you allow water from a tap flowing into the aspirator, then when the level of water increases, that means the air now will be being pushed into this delivery tube. Then will be allowed to enter into caustic soda, which is sodium hydroxide. So in caustic soda, sodium hydroxide is where now carbon dioxide dissolves to form sodium bicarbonate. And the air now will be also passing again through the heated copper turnings. Then through heated copper turnings, oxygen gas now will react with copper turnings and form copper oxide. Now nitrogen now will be the remaining gas together with inert gas that will pass now and be collected over water in a gas jar. So that is now how you can prepare nitrogen in the laboratory. So instead of using aspirator here, you may pump directly an air from the atmosphere by using a bicycle pump. How do you do it? You don't need to have again the aspirator here. So you just pump the air from the atmosphere directly entering into the sodium hydroxide. When it entered into sodium hydroxide, then carbon dioxide will be absorbed, and the oxygen will react with the heated copper to form copper oxide, and then the nitrogen gas together with the inert gases will be collected over water. So my dear students, that is a simple way of how can you prepare nitrogen gas from the atmosphere. Now let us see some chemical reactions of nitrogen gas. So we have the chemical properties of nitrogen gas. Now the first to consider is that it does not burn or support combustion. But when heated, it reacts with oxygen to form nitrogen monoxide. So when heated, it reacts with the oxygen gas and form nitrogen monoxide, which means that if this is nitrogen gas now reacting with the oxygen gas but being heated here, then the product is nitrogen dioxide gas. There must be two after balancing. So that is the reaction when nitrogen is burnt in air. Another reaction is that nitrogen reacts with the hydrogen gas to form ammonia, and this is known as Haber process. So nitrogen gas reacts with the hydrogen to form ammonia gas, and this is also known as Haber process. It occurs in Haber process. So here is that if we have nitrogen gas, then reacting it with the hydrogen gas, the product formed is ammonia. Ammonia gas is being produced plus heat. The process is exothermic. After balancing, that means here we need to have 2, and there we'll be having 3. So that is how nitrogen reacts with the hydrogen gas. Apart from that, we have the reaction of nitrogen with metals. Reaction with the metals is that nitrogen reacts with the metal but under heat to form nitrides. So here is that it reacts with the metals to form nitrides, but the reaction involves strong heating. So taking an example of magnesium, which is solid, when reacted with the nitrogen gas and strongly heated, they result into formation of magnesium nitride. So this is magnesium nitride. So these are the main reactions of nitrogen. Now, my dear students, after considering the reactions of nitrogen or chemical properties of nitrogen, let us now go and see or discuss some application or uses of nitrogen in our everyday life. So we have the uses of nitrogen. Application or uses of nitrogen. I know some of you are farmers, or if not you, but your parents. If not farmers, maybe you may be having garden of vegetables at your homes. So one of the application of nitrogen is that is used in the manufacture of fertilizer. So it is used in manufacture of fertilizers. And these fertilizers, we call them as nitrogenous fertilizers, which means fertilizers manufactured in industries, but they contain nitrogen as the main constituent elements in those compounds that make up those fertilizers. And the examples of fertilizers which are nitrogenous fertilizers, we have a fertilizer known as DAP. We have a fertilizer known as ASP. We have a fertilizer known as CAN. We have a fertilizer known as AN. We have a fertilizer known as SAP. We have a fertilizer known as urea, and etc. So these are some of the examples of nitrogenous fertilizers. Now, what does DAP stands for? DAP stands for D-ammonium phosphate. D-ammonium phosphate is a fertilizer used for planting and for nutrition of plants. Now we have ASP. ASP stands for ammonium sulfate phosphate. But also CAN stands for calcium ammonium nitrate. And also AN stands for ammonium nitrate. But SAP stands for sulfate ammonium phosphate. But also urea is the name it is. I know you remember, even urea in your body contain ammonia. Now, why do we call them as nitrogenous fertilizer? Because the main component here in ammonia we have nitrogen. Here there is ammonia that contains nitrogen, there is ammonia that contains nitrogen, there is ammonia that contains nitrogen. So even in urea we have nitrogen inside. So that's why we call it nitrogenous fertilizers. And they are very, very useful in agricultural activities. Now, another application or uses of nitrogen is that it is used as a refrigerant in refrigeration. So it's used in refrigeration, and this is due to its low boiling point, and the boiling point of nitrogen is about -196. So due to its low boiling points, it is used as a refrigerant. So for cooling purposes. And also, apart from refrigeration, nitrogen is also used as in plastic industries. In plastic industry, specifically here in the synthesis of what we call it nylon. And here nylon is a polyamide. This is a polyamide. A polyamide is a polymer made up by monomers known as amide that combine together to form polyamide. And the nylon now is also, in other name we call it polyamide. So the amide have this kind of structural formula. So do you see here we have nitrogen. So in manufacture of plastics, specifically nylon, we use amide as our monomer. And the application of nylon is used in manufacturing or in formulation of fish nets, also in formation of fibers like that, those which are used in formation of clothes. So all these are because of nylon, which is being manufactured in industries due to presence of nitrogen. My dear students, we have another application of nitrogen which is known as in manufacture of ammonia. In manufacture of ammonia. And here we have seen it during the discussion of chemical properties. Here is that nitrogen gas reacts with the hydrogen gas to form ammonia in the Haber process. After balancing here 2 and here 3, so to a ratio of 1:3:2. So ammonia have a very wide application in our normal life. Like what you have seen here, you can form ammonium salts through ammonia. Now, in Haber process, this is also called the Haber process. In Haber process, this is the process in industry where a large amount of ammonia are being produced. So that is another application of nitrogen. Okay, my dear students, another application or uses of nitrogen is in processing reactive substances. In processing reactive substances, this is due to inertness nature of nitrogen. We have said that nitrogen is very, very low reactive, so or is very less reactive. So due to that inert nature of nitrogen can be used for processing those reactive substances. So reactive substances can be carried by using nitrogen, and they cannot react with any other substances, which means that they cannot react with the atmospheric oxygen or atmospheric vapor, because they are inside the nitrogen, which is inert or which is less reactive. So that's why we say that it is used in processing reactive substances. Apart from this one, we also have another application of nitrogen is in manufacture. In manufacture of nitric acid. Here is that the ammonia produced during Haber process are being oxidized in this reaction for production of nitric acid. We call it catalytic oxidation. So ammonia produced in Haber process. In Haber process undergoes catalytic oxidation, to form nitric acid. And the production of nitric acid occurs in 3 steps. So we have steps involved here. Steps involved is that first, ammonia is being oxidized by oxygen into nitrogen monoxide, then plus water, then other product. You can balance the equation. So the second step is that nitrogen monoxide, the nitrogen monoxide gas is further oxidized in presence of catalyst into nitrogen dioxide gas, whereby the third step is that the nitrogen dioxide gas is being oxidized in presence of water and form the nitric acid. So my dear students, you can write the balanced equation. So it's your task to balance that equation. So these are the main 3 steps involved in formation of nitric acid. And I know you know the application of nitric acid. Even in your laboratory, you are using in different experiments, that is nitric acid, and in production of other products. Now from there, my dear students, normally nitrogen is neither acidic nor basic. So which means that even if dissolved in water, they do not dissolve in water, is what we have seen there. That's why during preparation it is corrected over water. So is also odorless and is also colorless. So those are physical properties of nitrogen that you can you can note them in various questions that may come and ask you in explaining the taste. It is tasteless. Odor, it is odorless. Color, it is colorless. So you cannot see it. Even in the atmosphere here, where we are now, we have nitrogen, but you cannot see it because it is colorless. From now, our discussion that we have discussed here, let us now see some questions that employ you to use the knowledge that we have discussed in answering these questions. So my dear students, now the first question is this one, that Form 4 students prepared a gas jar containing nitrogen gas. Then they introduced damp red and blue litmus papers to the gas jar. Then what do you think would happen to red and blue litmus paper? Is the gas acidic or basic? Explain. So the question is so simple. Since we have discussed it, I know that you now have the knowledge of nitrogen. The question first part A is asking that would a red litmus paper change or a blue litmus paper change? Normally here is that neither of the litmus paper would change, which means that neither blue nor red litmus paper would change. Why? Because nitrogen gas is neither acidic nor basic. So the blue litmus paper will remain as a blue, and a red litmus paper will also remain as a red. So part B, we have been asked to explain that if the gas acidic or basic, then explain. So here we say that the gas is neither acidic nor basic. Then you have asked to explain. How do you explain it? You can just say that if it could be acidic, a blue litmus paper could turn red. That is the first reason. But the second reason is in case of red litmus paper, which means that if it could be basic, it means that the red litmus paper could turn blue. So that is how you can answer such kind of a question. So my dear students, let us go now to question number 2. Question number 2 is that magnesium ribbon in a crucible was burnt in a gas jar containing nitrogen gas. The product formed was allowed to cool, and later a few drops of water was added to the product. Now, A, what do you think happened to magnesium ribbon in the crucible after burning it in nitrogen? B. Write a well-balanced chemical equation for the reaction which took place. And C. What do you think happened after adding water to the product? And D. Write a well-balanced equation for the reaction in C above. The question is so simple, since it is about nitrogen, and the nitrogen was reacting with the magnesium ribbon. So this is question number 2. The first question, we are being asked that what do you think happened to magnesium ribbon? Normally, magnesium ribbon burn by producing sparks or white, resulting into formation of magnesium nitride. So the reaction is that what happened now for part A is that sparks of bright flame resulting into formation of magnesium nitride. So that is what could happen. Now the second part, which is B, we are asked to write a well-balanced chemical equation for the reaction which took place, which means that when magnesium ribbon was burnt in gas jar containing nitrogen. So it is magnesium ribbon, which is solid, now burnt in gas jar containing nitrogen gas. Then here we get magnesium nitride. So this is our product that would be formed. So you can balance the equation, my dear students. I think since here is 3, then you can put 3 there. So that is now about part B. But part C is that what do you think happened after now adding water to the product? That means adding water to the product, which is magnesium nitride. So here, adding water to magnesium nitride is the reaction between magnesium nitride and the nitrogen gas. Magnesium nitride solid and water. Here the reaction results into formation of magnesium hydroxide and the ammonia gas, and the ammonia gas. Now this is for part C and part D, because we were asked what do you think happened after adding water to the product. Now what will happen here is that a gas with the pungent choking smell formed, which is an identification characteristics of ammonia gas. So it is a pungent choking smell. Now to write now the well-balanced equation for the reaction, now this is our reaction. So here it is for A and B, so this is for C, but for A is that a gas with pungent choking smell is observed, because we are asked that what would happen. Now to balance the equation, you can balance. Here we have 2 nitrogen, then you can put 2 nitrogen there, but you have 6 hydrogen, 2 hydrogen, but here we need to have 3 magnesium. So here there must be 3 magnesium. So 3 magnesium, 6 hydrogen, then 12 12 hydrogen, so we put 6 there. And 6 oxygen here, 6 oxygen, so the equation is balanced. So my dear students, this is how you were supposed to go about that question. Now let us see the last question. The last question is that we have been given the diagram here, this vessel representing A, and this is B, this is C. So if this is A, this is B, this is C, we are told that study the figure below and answer the questions that follows. So the questions that follows after observing this diagram. Now, part A is that what does letter A, B, and C represent? I know you have observed the diagram whereby this is question number 3. A stands for aspirator, whereby this is A, so A stands for aspirator. A stands for aspirator. That vessel is known as aspirator. And the B stands for, let us go back to our diagram. This B here stands for gas jar, and the C stands for water. So we have gas jar, and the C stands for water. Now we are also asked to suggest the title of the experiment. I know you know how that the diagram looks. Here on our diagram we have nitrogen gas, so that means the setup represents the laboratory preparation of nitrogen gas. B therefore will be a laboratory preparation of nitrogen gas. Now if we go and consider part C, what is the function of sodium hydroxide? Write its reaction equation. Do you remember when we were talking about the laboratory preparation of nitrogen gas? We said that the air from the atmosphere must be passed through sodium hydroxide. For what, my dear students? Do you remember? Yeah, it's for absorption of carbon dioxide. So C is that sodium hydroxide. What is the function of sodium hydroxide? Is to dissolve carbon dioxide, and is just to dissolve carbon dioxide. And we are asked to write down the chemical equation. The chemical equation, that means it is now sodium hydroxide, which is an aqueous that reacts with the carbon dioxide gas, then resulting into formation of sodium bicarbonate. So if the equation is not balanced, then you can balance it. So that is the reaction equation. You are supposed to write it. Now E is that write the equation for the reaction that you think took place. Is that what we have written here? So my dear students, that is how you can answer such kind of question. We have assignment question for you to do it to measure your understanding. So that give the uses of nitrogen in which A, the inert nature of nitrogen is applied. So write it please. Give the uses of nitrogen in which the inert nature of nitrogen is applied. B, the low boiling point of nitrogen is applied. So this is an assignment for you. Now for references, you can pass through these 3 books. We have a book known as Chemistry for Secondary School, Book 2, written by Tai. We also have the second reference is Chemistry for Secondary School Form 4, revised edition, that is for Oxford University. We have the third reference, which is a new certificate chemistry 4th edition, commonly known as Lambert. Through passing through these references, you can have more knowledge on our discussion. So my dear students, I think you have enjoyed our discussion from the beginning up to this point where now we close or we end our lesson. So keep on watching Darasa online. Goodbye.
Kutana nami katika kipindi cha Chereko kila siku ya Jumapili saa 11 jioni. TBC, ukweli na uhakika. Marudio Jumanne saa 9 alasiri. Usikose.